Okay, so there are a couple of minor enhancements made available today with the release of version 9.0.5. The first of which is the ability to draw horizontal lines onto the light curve plot. And this is a fairly basic and simple feature, but it is nonetheless quite helpful whenever you are trying to align different photometry sets and adjust the magnitude offsets between them. The other enhancement is the ability to adjust how the sky background is computed, and I will go over that in more detail in a moment, but for now let's go ahead and get started with that first enhancement. So I'm going to go to the Tools menu, Lightcurve Database, and if you have watched my previous video, I've gone over this in a bit more detail, so if you want to learn a little bit more about how to use the Lightcurve Database, that video is available. But for now I'm going to work with that same object. This is asteroid number 1884, also known as Skip. So I click on it, I choose Import Object, and that brings up 5 different photometry sets. So a photometry set is simply a collection of photometry data points, usually taken on some night throughout the year. So here we have November 11, 23, 24, 28, December 24. So these are different nights of data taken throughout the year, and the goal is to try to compute the rotation period of this asteroid using this data. So I am going to go to Graph, Plot All Sets, and this is a good example because you'll notice that not all of the data points are visible. So if you wonder why that is the case, I always recommend to go to Graph Settings, so the Graph menu, Settings, and you'll notice that the magnitude axis range is set to fixed range, 0.2 magnitude. So whenever you are starting off with a new set of data, raw data that has yet to be corrected, then I recommend using floating. So the floating option is going to show all of the data points. So as you can see, we do indeed have 5 different photometry sets. We have 1, 2, 3, 4, and the 5th one here, again, December 24th, so taken much later than these others. And what we can go ahead and do is, if we want to, just try to find the rotation period. Now this is without any corrections applied. So as you would expect, this is these returned rotation periods are incorrect. So here's the period list. These candidates, none of them in the first 10 are close to what we would expect for this asteroid. And so again, we expect that because we've not made any corrections, we've not aligned any of the data sets. So let's go back to the raw plot, and the first thing you want to do is we want to populate these columns. So we want to have the ability to do light time correction, magnitude. The absolute magnitude will allow us to do H minus G correction. And so all of these columns are useful in some way, shape, or form. So to populate them, we go to the photometry set window again. So go back here, select all of the photometry sets, and then right-click and choose Apply Object Data. So this is a known asteroid. It has a number and a name. So you can use either one. So click Search, comes back with a result, click OK, and now you'll notice that these columns are now populated. Now, except for the SNR, the signal noise ratio column, and that is because this is an imported object. So these imported objects, they do not have that information available. However, whenever you are creating your own measurements, that column will be populated. But for now, again, the enhancement was the ability to draw these horizontal lines. So the purpose behind that is to facilitate aligning these photometry sets. So let's go back here and let's redraw the graph. So plot all sets. And now you'll notice that because we have those columns, it is by default going to apply light time correction as well as H minus G correction. And these photometry sets are now lined up much better than they were as a result. But we're still not quite where we want to be. If we want to, we can try to do a fine period, and it does look better. 5.79 and 2.89. Those are both potential candidate rotation periods for this asteroid. But as you can see from the phase plot here, the photometry sets are not yet lined up how we would want them to be. So I go back to raw plot, and again, that enhancement, well, we can now draw horizontal lines. So that could be solid, dashed, or dotted. So as you'd expect, a solid line looks like that. My favorite is the dotted line. So you could choose that view if you want to. And what I'm going to do is go ahead and line these up. So I drag a rectangle over the photometry data points I want to work with, make that selection, and then I could either right click and choose a given offset from this menu, or I could use the arrow keys. So if I hold down the shift key, that will reduce the granularity. Control key makes it even more reduced. If I don't have any of those modifiers, then it's quite a change. So anyhow, you can make your adjustment here. I'm just holding down the shift key while using the up or down arrow key. And that it does not have to be perfect, but we can go ahead and make this adjustment and then see what kind of result we get with the period. So again, if you have to zoom in, you can adjust these markers on the horizontal axis. So I zoom in, select the data points, and I can zoom out if I want to. And again, make the adjustment. And this looks pretty good. I'm almost where I want it to be. So at this point, we can go ahead and do a fine period. And that looks pretty good. So I've got 2.894875 is the top result. And if you consult the PDF document I mentioned in that previous video, that is in fact the correct rotation period for this asteroid. And we can actually go ahead and go back to the fixed range, 0.2, and that looks pretty good. So this is a way in which we can align those photometry sets in a desirable way. So if you make a mistake along the way, if for some reason maybe you partially selected some of these data points and did something like that, you can always drag a selection over it again and choose Reset Offset. Now if you have to reset all of them, you can drag a rectangle over the entire area, choose Reset Offset, and then you're back to where you started. So again, that's this minor enhancement, but it can be helpful whenever you are trying to align these photometry sets. Now, the next enhancement I talked about was the ability to adjust the computation of the sky background. So if I go to the image manager, I add up an image, then what we can do is just do a little experiment here. So I'm going to look at a star here that has a nearby neighboring star, and that would count as interference in the sky background. So if we go to the photometry menu, we now have this new menu item, Modify Sky Computation. Now these are the default settings. So if I click Restore Defaults, you'll see nothing changes. These are the defaults, and I highly recommend that you do not change these settings. Only if you are an advanced user and you know exactly what you are doing, only in those circumstances should you potentially change these settings. But otherwise, I highly recommend to use the defaults. So what we can do to experiment with this, you can do right click, view object profile, and you'll notice this is the star that I am centered on, and here is the nearby star that interferes with the sky background. To show that in more detail, I can go to modify Aperture Settings, and you'll get the display showing the inner radius, and then you have dead zone, and then you have the sky annulus. So this star here is inside the sky annulus, and it does impact that sky background. At least it ordinarily would, but the default setting here is to divide into quadrants. So by dividing it into quadrants, we are able to mitigate the impact that this star has on the sky background. So if I uncheck these boxes, that one, as well as remove outlier samples, then you'll notice the profile here, it has now a much elevated sky background. So that sky background value has been elevated beyond what it would ordinarily be. And again, that's because we have this interference from a nearby star. So that's why there's the default settings, but there may be a scenario in which you wish to change those defaults. So this also manifests as well for this brighter star, but it's not quite as noticeable. So here's the defaults, and here you have the interfering star here, which is not quite as bright as the host star, if you will. This is not necessarily a binary system, but again, just to show this, if I uncheck these boxes, you'll notice that that sky background has now been elevated beyond what it ordinarily would be. So just something to keep in mind. It is now an option. You can now adjust this setting, but I recommend the defaults. So that's about it for this video. I want to thank you for watching and see you next time.